Logarithmic graphs are very similar in how they look to exponential, except they look like they're turned over on their side. So as you see this log graph, the characteristics of them is they rise sharply. It seems like they don't go past the y-axis. So, you know, if you extended this down, they're just going to keep going down, but never cross over the y-axis. And they're always going to rise as you go to the right, but as you get further in the x category, it rises slower and slower, but it'll still rise all the way up. So the characteristics, they rise sharply and slowly increase as x increases, because remember, you're solving for exponents, and exponents can get can yield really large numbers. So that's why it slowly increases, because when you raise it to even a smaller power, you can get a really large result. So what happens is log graphs have a vertical asymptote. So that vertical asymptote is, if by the default function here, if it's not shifted or anything, it's going to be 0, x equals 0. So the y-axis is x equals 0. And that is the vertical asymptote on the parent log graph. So any parent graph that has whatever base there, if there's nothing being added or subtracted in there, it's going to stay put. So if I typed x equals 0, you'd see a vertical line right on the y-axis. Now we can shift these log graphs left or right, up or down. So let's start by shifting it right. If I shifted the graph right, so if I did -3 inside of the parentheses, then that's going to change the vertical asymptote to x equals 3. So if it's -3 in the parentheses going right 3, vertical asymptote is x equals 3 now. So that brings it over to match it. And that doesn't really matter what you shifted. If you shifted it right 5, then the vertical asymptote would be x equals 5. So it's just going to match up whatever you go on there, opposite signs for the asymptote. Same thing going left. If I decided to go left 3, then that vertical asymptote is going to be, well, if I did +3, then that vertical asymptote would now be dragged to x equals -3. So it's going to follow wherever the shift you do, and again, it's going to be the opposite of the sign in here. So the vertical asymptote -3 because it went left 3. And remember, with left or right movements, any function, same rules apply. If it goes left, it's going to be plus inside the parentheses. If it goes right, it's going to be minus inside the parentheses. So we can shift things up or down. That won't change the vertical asymptote. So if I decided I wanted to go, you know, up 3, I could add 3 to the very end of the equation after the parentheses, but that's not gonna move it left or right, so that vertical asymptote would still be 0. And the same thing with -3. So if I subtracted 3, it's gonna go shift down 3, but it's not gonna shift the asymptote, so it'll still be 0. So up, down, either way, it's the number outside the parentheses. Up is plus, down is minus. Let's review those one more time. Going right is going to be minus in the parentheses. Left is plus in the parentheses. Up is plus outside the parentheses. Down is minus outside the parentheses. And up or down does not affect the vertical asymptote, just the left or right. So let's go over another example. We'll do this one together. We want to describe how the function transforms. So we have our parent function, y equals log base 5 of x, and it gets transformed into y equals log base 5 x plus 4 minus 2. Log base 5 x plus 4 minus 2. I want to describe how the function transformed and what is the new vertical asymptote of the transformed function. So let's start with transformed first. X plus 4 is going to be left 4. And then minus 2, that's going to be down 2. So it went left 4 and down 2. Because it went left 4, the vertical asymptote would be x equals -4. We can check that on Desmos. What you would do is you would type in first type in y equals log shift minus 5, base 5 of x. Get that parent function in there. And then we can move it in the parentheses +4 and outside the parentheses -2. So I'm going to copy this because I want to keep the original function in there to compare it. So I'll say +4, and you can see that moved it left 4, and then -2 shifted it down 2. So it went +4, left 4, down 2, and then your vertical asymptote is x equals -4. All right, +4, left 4, -2 on the outside, down 2. Left 4, down 2, x equals -4. Try this one on your own. Pause the video, see if you can answer these two questions. Okay, hopefully you've had a chance to check it. Let's go through or do the problem. Let's go through and check it. This one is telling you what movements it did. We want to write the new function. So it's log base 2. So we're just going to start with log base 2. That's going to stay the same. That number, whatever's in the base there, is going to stay in the base. So let's talk about what happens if I shift it 3 units to the right. Well, right is going to be this way. It's minus on the x-axis. Remember, it's the opposite. So it's going to be -3, just like any function. And 4 units down on the outside, that'll be -4. So hopefully you have log base 2 of x minus 3, and then -4 on the outside. On part B, what is the vertical asymptote of the transform function? Well, it's always going to be x equals. And since this is -3, it's going to be 3. Since it went right 3, that vertical asymptote went from 0 to 3. So hopefully you can see that connection. The asymptote will be the opposite sign of the number in the parentheses. So we'll go ahead and just check that one more time. Let me change this to a 2. And we want it to be -3 in the parentheses and -4 on the outside. So -3 and -4. And we're going to change this to 3. All right, so let's compare. So log base 2 of x is the green function. That's your parent function. Oops, I should make that a 2. There we go. Log base 2 of x minus 3, -4. It went right 3 and down 4. So pick a point to kind of compare, right? 1, 0, if I take that right 3, that's going to give me 2, 3, 4. And down 4, 1, 2, 3, 4. That point, +4, -4, is right 3 and down 4. That happens to be on our new graph. So we know we did the right movement. And it looks like x equals +3. The graph will never go beyond that on the other side of it. So everything's good.